Hello and welcome to the channel. If you're new, please drop a like, leave a comment, subscribe if you haven't already. You know what to do. Without further ado, let's get into today's topic, which will be factors, multiples, and prime values along with prime factorization. Because these three, I'd say, they walk hand in hand, and it might be quite a long video, but just bear with me. So the first thing I want to explain is multiples. What are multiples? Well, simply put, multiples is, you remember back in little school, I'd call it, you counted in specific values. So for example, you counted in fives, or you counted in tens, or you counted in 20s or twos or whatever. Now that is what multiples are. Multiples are basically, say I start at 2, then it's 4, 6, 8, 10, 12, and so it goes on. So that is basically what multiples are. Another value, for example, 5, 10, 15, 20, 25, 30, and so it goes on, and probably goes on to infinity. This is the base of what multiples are. Now, multiples are useful for finding the smallest common multiple, and factors are useful to find the greatest common factor, which is the GCF, or the HCF, which is the highest common factor. And with that being said, let's talk about what are factors. Factors, they might be difficult to understand at first, but they are really simple. What factors basically are, and I like to explain this using a factor tree, right? Factors of a value is, say we have the value 10. Let's just use 10. It's very simple, very easy. Now, factors are basically values that multiply into a specific value. So this specific value that we chose is 10. 10 is basically, I'd say, our reference value. So how I like to go about it is I build it from side to side. So I don't know, you can probably call it the side to side method, the side step, I don't know. So we know that 1 times 10 is 10. So there are two factors of 10. We know that 2 and 5 multiply to give me 10. So they are another two factors of 10. And these are the four factors of 10, because there's nothing else that we can multiply with each other that will give us 10 that are whole numbers. So with result that these are the two out of the four factors of 10. If we take another value, for example, let's say 20, right, which is a bit bigger, again, we go from side to side. First two is always going to be 1 and the value itself. 1 and 20 are factors. 2 and 10 are factors, and 4 and 5 are factors. So these are the 6 factors of 20. So again, I just want to reiterate, factors are basically values that you multiply with each other to give you a specific value. So 20 has the factors 1, 2, 4, 5, 10, and 20. 10 has the factors 1, 2, 5, 10. And that is basically it. That is what a factor is. So the next thing I want to touch on is prime values. So what are prime values? Well, the precise definition for it is a value that can only be divided into one and itself. So unfortunately, there's no real method to remembering the prime values. It's basically, you just have to go and sit and study them. But as time goes on, you will sort of intuitively understand what prime values are, and it'll be a lot easier for you to actually pick up if a value is prime or not. So prime values like 1 is only divisible by 1 and itself. 2 is divisible by 1 and itself and nothing else. 3, 5, 7. Now at this stage you might think, okay, well, the rest is just uneven numbers. Not the case. 9 is not a prime value because it is divisible by 3. So the next prime value is actually 11. 13, not 15, but 17. 19, not 21, not 22, but 23. Not 25, not 26, not 27, not 28, but 29. And so the list goes on. But I'd say these are the most important prime values that you'll have to know. And again, it's just a matter of remembering them. And then the next thing I want to talk about is prime factorization, which could be difficult, but I reckon it's not that difficult. So a lot of you might have been taught the stem and leaf method, which I will go through, but I want to focus on the factor tree. So we build factor trees. So say we have a value like 28, right? Then all we have to do is build the factors of 28. So 28, 4 goes into 28 7 times, and there's our first prime value, right? Because 7 is a prime value, so there's one of our prime values. And then we look at 4. Well, 4 is 2 times 2, which is basically equal to 2 squared, right? So they're both prime values, so they are prime factors of 28. And how do we write that? Well, we could say 28 is equal to 2 squared times 7. Now, the method that I think you guys use most predominantly in school is the stem and leaf method. If you're allowed to use the factor tree, rather, it's a lot easier. The stem and leaf method is a bit more tricky. So what you have to do with the stem and leaf method is you have to find a value or a prime value that is divisible by 28, or that 28 can divide into. So it's not that difficult. I guess there are a few tips I can give you on if this is the only method that you're allowed to use on how you can optimize and do it more efficiently. And that would be, if it's an even number, it's always going to be 2. That's the simplest way to go about it. Just use 2, right? So if I use 2, I know that 2 goes into 28 14 times. Now again, I can say, well, 2 goes into that 7 times, and 7 goes into itself once. Now, if you notice that it's exactly the same prime factors, right? So again, I can say, well, 28 is equal to 2 squared multiplied by 7. Now, say it's not an even value. The tips I do have for you is, say it is a value like 15, right? So I'm using very small values just to kind of get the point across. Now, if you want to know if a number is divisible by 3, you just add the numbers of that number. So 1 and 5 is 6. 6 is a multiple of 3, which means that 15 is divisible by 3. Right? So what I mean by that is 1 plus 5 is equal to 6. Right? And we know that 6 divided by 2 is equal to 3. So 15 will be divisible by 3. So I can put 3 in because 3 is a prime value. I know that 3 goes into 15 5 times, 5 goes into itself once. So the prime factors of 15 is equal to 3 times 5. And that is it for this video. If you guys want me to do a bit more examples of prime factorization, if you're not quite understanding it that well, please comment it down below and I'll see if I can kind of get a bit more examples going and do a bit more examples with you guys. But yeah, that is it for this video. If you enjoyed it, if you found it educational, please drop a like, comment, subscribe if you haven't already. You know what to do. And that is it for this video.